In today's class, we are going to solve aptitude PYQs. This is part 5. These questions are from GATE 2025 𝐂𝐍𝐃𝐑𝐎𝐻 PI papers. All these papers were conducted on the same day and same shift. Therefore, aptitude questions are same. Okay. But engineering mathematics questions were different. Nevertheless, in today's class, we are dealing only with the aptitude. So, let us start the lecture with the very first question. Courage is to bravery, yearning is to what? Select the most appropriate option to complete the analogy. We have 4 options. Pause the video, try by yourself, then look at my solution. Tried? So here, courage is to bravery. We can see synonym. Leader is courageous and brave, so synonym. Yearning synonym is what? Longing, yelling, yawning, glaring. So you should know first what is yearning. It is strong desire. So synonym of strong desire is longing. I'm longing for you. I have a strong desire for you. Okay. So that makes sense. Yelling is not desire. You are shouting, you are yelling at someone. It is not a desire. Yawning, when you are sitting in not my lecture, in your college lecture, you yawn because there is no desire to learn. But in my class, you do not yawn because you have desire to learn, right? So this is opposite of desire, doesn't make any sense here. And glaring is wrong because glaring means you are angry at someone and you are looking angrily to him. Okay, that is glaring. So correct answer is option A. If you are just referring the notes, you will get first 10 questions of the aptitude and then question, answer key and detailed solution slide, so that you can save time and just go through the notes. But if you are a repeater, you have a lot of time, you can watch the lecture, or else if you feel in some solution I need the video lecture, you can just open the lecture and watch the class. Okay, always save times. Time is the valuable asset in the GATE preparation, so keep that in mind. Let us go to the question number 2. We dash tennis in the lawn when it suddenly started to rain. Select the most appropriate option to complete the above sentence. We have 4 options. Pause the video, try by yourself, then look at my solution. Tried? So here, we dash tennis in the lawn when it suddenly started to rain. Surely, this sentence is about the past, right? We dash tennis in the lawn when it suddenly started to rain. So it is about the past. So the simple way to solve this kind of question is take the option, place, read the statement and think whether it makes sense or not. If yes, right. If no, wrong. Okay, option A says, we have been playing tennis in the lawn when it suddenly started to rain. We have been playing? No, that doesn't make sense because the context here is you are doing some continuous action and there was an interruption due to rain. All these things in the past, okay? You were doing something in the past and there was an interruption due to rain. Okay. So we have been playing is like present tense, but we are in search of past tense. This is wrong. We had been playing, had, past, makes sense. We would have been playing. This is something like you are thinking of some hypothetical action which is not occurred yet, but we were doing some action in the past. We are doing some action. There is no hypothetical action. Okay, so we would have been doing is wrong. We could be playing is also wrong. It is about the future, but the context is we are doing some action, not some hypothetical action, not some future event action, but we were doing some action, that is playing tennis. So we had been playing tennis because we are dealing in the past when it suddenly started to rain. Makes sense. So option B is correct. Understood. Question number 3. You have seen the answer key. Okay, try this question by yourself and then look at my answer. So this question is pretty easy, level 1 question, because they are saying a 4x4 digital image has pixel intensities U as shown in the figure. The number of pixels with U less than equal to 4 is. You have to find how many pixels are there which is less than equal to 4. Very basic, even school student will solve this question. See, 0 less than equal to 4, yes. 1 less than equal to 4, yes, yes, yes. 4 less than equal to 4, equal is there, so yes. 7 no, 3 3 5 no, 5 no, 4 yes yes, 6 is not less than equal to 4, 7 is not less than equal to 4, 3 yes yes. So all these circled players are less than equal to 4. So number of this circled player is here 4, here 3, here 2, here 2. Add them out. 4 plus 4 8, 8 plus 3 11. 11 is the correct answer. Option C is correct. Easy. I told you, very easy. But not all questions are easy. Try this tough reasoning question. Pause the video, try, then look at my solution. Tried? Okay. The question says, in the given figure, the numbers associated with the rectangle, triangle and ellipse are 1, 2 and 3 respectively. Which one among the given options is the most appropriate combination of PQR? So we can see combination of PQR, which is the appropriate as per the diagram. Now when I was seeing the diagram, I understood this 1 represents the rectangle, 2 represents the triangle and 3 represents this ellipse. But this PQR we have to find, and what is this 4 doing here? So somewhere this 4 has some significance to the logic building, and from that logic I will get my PQR values. This is how you have to think. Now the problem with the reasoning question is logic is not predefined. As per the situation you have to develop. So some student will think 4 means this region. Maybe this region is connected to 4 neighbors. 1, 2, 3, 4. Like that they are thinking. So 4 neighbors, so 4. If in the same way I check for P, how many neighbors are there? So let me start. Let me think. For P, I can see this is the region, right? For P, this is the region. So I can see 1 neighbor here, 2nd, 3rd, 4th, 5th. 5 neighbors are there. So 5 neighbors, you might be thinking like this. But you have to also check for Q and R. If Q has 6 neighbors, R has 3 neighbors, makes sense. So I was thinking of Q then. If P is 5, not here, here also P5. Q has how many neighbors? 1. Then see, Q is this region. Just to make sure you understand, this is the region. So 1 neighbor, 2 neighbor, 3 neighbor, 4 neighbor. 4 neighbor, not here, not here. So this logic is wrong. If you are playing neighbor, this logic is wrong. You have to think of something else. Then I was thinking at the data. Why they are saying rectangle is represented 1, triangle is represented as 2, ellipse is represented as 3. Some significance should be there to this shape and number. So I was thinking 4. This region is covering. Rectangle is there and ellipse is there, but no triangle is touched. See, we are not inside the triangle region. We are definitely into the rectangle and ellipse region. Isn't it so? See, triangle is here. Triangle is here and this is the region of the triangle. So our 4 region is not inside the triangle. It is inside the ellipse and it is inside the rectangle. So this 4 is made from rectangle and ellipse. If rectangle is 1, ellipse is 3, so addition of that is 4. So is it the addition operation going on? If 4 is the region made from this 2 shape, then add their numbers. Is this the logic? So if that is the case, let us investigate for the P. This P is made from which regions? It is inside the rectangle. It is also inside the ellipse. It is also inside the triangle. So this P region is made from rectangle, triangle and ellipse, all of them. So 1 plus 2 plus 3, it is coming out as 6. 6 not here, not here, not here, only here. You might be thinking, but I won't click unless I can verify Q and R as well. Maybe this logic might be wrong as well. So let me analyze for the Q now. Q is here. It is inside which regions? Ellipse and triangle, not rectangle. Rectangle is here. Q is outside of the rectangle. So Q is made from only it is inside only two region, which is triangle and ellipse. So triangle was 2, ellipse is 3, 2 plus 3 is 5. So Q should be 5, makes sense. Now you should take, makes sense, but I will just for the verification check for the R. So now R, in the exam this 2 is okay to go, but still for the R we'll investigate. R is inside the rectangle and inside the triangle, but not the ellipse. R is outside the ellipse, so avoid the ellipse for R. Triangle and rectangle makes sense. Rectangle 1, triangle 2, 1 plus 2 is 3, so 6, 5, 3, absolutely correct. Let us go to the next question. Pause the video, try, then look at my solution. Tried? Okay. The question says a rectangle has a length L and width W. L is greater than W. If the width W is increased by 10%, which one of the following statement is correct for all the values of L and W? We have 4 options. Pause the video and try, then look at my solution. I guess you would have solved this pretty fast because similar question we have done in the class, right? See, we have rectangle. Suppose this is the length L, this is the width W. Now they are saying we are creating new rectangle where length is same as the previous, but width is changed. Width is increased by 10%. So W into 1 plus 10 by 100. This is how you increase. 1 plus means increment, 10 by 100 means how much percentage? 10%. So this is how we represent. Now you have to comment on the rise. So one option is saying the rectangle now becomes square. Not necessary. Whenever any statement is framed, we assume that it is 100% true for all the cases. So this might be true for some case, but not for the all case. Therefore, this is wrong. We are left with 3 options. In the exam, go with the easiest option to start with. Area is the easiest because area is for the older one length into breadth, which is W here. For new rectangle, what is the area? L into W dash. But what is W dash? W into 1 plus 10 by 100, which is 1.1. Okay. So percentage increase is final minus initial value upon initial value into 100. Final value is this thing. LW into 1.1 minus initial value is LW divided by LW into 100. So we are going to get the answer. LW is cancelled throughout. This calculation is now 1.1 minus 1, which is 0.1 multiplied with 100. 0.1 multiplied with 100 is 10%. So yes, 10% increase in the area you will see. This is absolutely correct. No need to check for A and B. Done. In exam, you have to solve like this. But as a teacher, I will explain why option A is incorrect and same logic goes for the option B. Option A says perimeter increase by 10%. So we need the initial perimeter and the final perimeter. Initial perimeter will be length plus width plus length plus width, which is 2 times length plus 2 times width, right? The final perimeter would be length is same. So L plus L 2L, but width is W dash. So W dash, W dash. So 2L plus 2 times W dash. But W dash, you know, it is W into 1 plus 10 by 100. So this is 1.1 multiplied with 2, so 2.2. So this is what you will get the new perimeter, 2L plus 2.2 W. What is the percentage increase then? Final perimeter minus initial perimeter upon initial perimeter into 100. This value minus this value would be 2L gone. 2.2 W minus 2 W is 0.2 W. So 0.2 W in the numerator, denominator is 2L plus 2 W into 100. So you can see that our percentage increase depends on L and W value. We can't say always it is 10% increase. It depends on L and W value. Therefore, we can't say always 10% increase. This is wrong. And in same way, option B is also wrong. And therefore, the correct answer is option C. Understood? So in exam, you can solve this pretty fast if you know how to solve. If you go option by option, it's time waste. Question number 6 in front of your screen. Column 1 has statements made by S and column 2 has responses given by K. You have to match the column and tell which option is correct. The fun part is P is matched with different responses. Q is matched with different responses. So just solve P and Q and you will get the answer. So these are the statements, these are the responses. Tried?